Okay, we're going to talk about the setup for the 70-degree shear. When we set up the 45, we just went in and peaked up on the ID corner trap signal at the end of leg 1 for 0, and then at the end of leg 3 for velocity. We kept going back and forth until we had a good cal. And that was based on peaking up. And we found the right velocity. Then when we went to the 60, we used that same velocity, and all we needed to do was find a new 0 to bring the cal in. Of course, for all three of these angles, 45, 60, and 70, we're setting them all up to be 1-inch deep screens. So we have these unique numbers that we use for the screen range to get 1-inch deep screens. For the 45, it's 1.414 inches. For the 60 degree, it's 2.0 inches. And for the 70 degree, it's 2.924 inches. Kind of an odd number to remember, but that's one of our magic numbers. So for our 70, we're going to set it up in a completely different way, actually. We're going to just set it up based on probe position. We're going to use that same velocity. It's the right velocity, but we need to find a new 0. And this time we're not going to do it based on peaking up. It's going to be based on the probe position. And as an example, let me grab a bigger fast probe so it'll be easier to see. But the principle is the same if it's a fast probe of some kind or a shear or a 70 shear. The fast block, this is a 1/2 inch thick block, and it's made for 70 degree. It was made for fast, which is 70 degree L wave. So we're going to be working now on the 70 degree shear wave, which is going to be a similar setup to the fast setup. And we're just going to do it based on probe positioning. We're going to take the index point, that point right there, and put it right on the mark for the 300 hole. Point it towards the 300 hole, and use our 0 function and dial it right in until it says that reflector is 300 deep. And that's all there is to it. The reason we like this is because on the thin material that we work on for pipelines, frequently, instead of doing traditional indication plotting, we'll do surface distance measuring checks. That works better for this thin material than indication plotting. So we're going to, when we think we have ID connected flaws, we're going to do something like this. If we think we have an ID connected flaw, we're going to take our 70 degree probe and move it until we find the position where that reflector is at the depth of the thickness of our material. We're using 300 thick notch blocks to cal, so let's make believe it's a 300 for now. Anyway, it's a big beam spread on the 70, and you could walk that to any depth you want, really. So you want to walk it to where it's 300 deep. That makes, because the machine has been told in its trig functions that it is a 70. When that's walked to 300 deep, 70 is pointing right at it. And if you take an accurate surface distance measurement, that's the most precise way to get an accurate surface distance measurement. And if you can do that from both sides, you could verify an ID connected flaw. When you do that plot from both sides, that surface distance plot should plot to the same point if it's a crack. If you've plotted it, surface distance plotting, and they cross over each other, then it's a geometry signal or something else. If you're not plotting to here with both of your surface distance measurements, you need to go back and recheck and see what you're doing. So we're going to go and do the complete setup for 70 degree. Okay, so let's go ahead and start setting up our 70. So let's flip our instrument back on. I think we left off on the 60 last time we were working here. Yeah, we were on the 60. All right, so plug that in, and we'll change from the 60-degree wedge to the 70-degree wedge. Okay, that felt good. Okay, so we need to go ahead and change a couple of things. We're going to leave the velocity the same. We're going to change the range to the range we need for a 1-inch deep screen with a 70, 2.924. All right, 2.924. And the x value, which is the distance from the index point to the front of the shoe, let's put in an initial starting number of, looks like 250. So go to the trig, change the angle from 60 to 70, and we'll change the x value to 250 for now, starting point. And we should be able to get ourselves started. All right, kind of hard to see that index point. I might have to keep moving the block around to get the reflected light so I could see it well. We've got our notch marks on here. For sound traveling in this direction, there's our notched mark for the 100, the 200, the 300, the 400. So we're just going to put this, we're just going to put the index point right on the spot for the 300. I might have to add a little gain. Whoops. Put that back to 250. All right, dB. Okay. I'm on the right location, and yeah, that came out perfect. I didn't have to do any adjustments of the zero. I wasn't expecting that. All right, so we're right there. Let me re-put that on the spot. I guess maybe I have to adjust the zero a very tiny amount. All right, and ideally when we have this in there correctly, I should be able to put that index point on each of these four spots for the 1, 2, 3, and 400, and they should come out very close to 100, 200, 300, 400, and we're done. Okay, let's see, it's right on the spot for the 100, very close, right on the spot for the 200, very close, right on the spot for the 300, very close, right on the spot for the 400, very close. So I'm gonna call that good. So let's we want to check our surface distance minus x value function. So let's see. I think I want to do that on the 300 block. I could pick any one of these. I'm gonna use the 90 notch. I'm gonna walk that to 300 deep, which I'm right there. And when I measure with my scale from the front of the search unit to that corner trap signal, I want it to match what I see in the surface distance minus x value reading box. And I'm seeing that as, to my eye, 480. So my X value is off. So I'm going to go in and adjust my X value until I see 480 here. Alright, that looks good. So let's see how that works over here. Let's try this. Let's go put that on the index point, right on the mark for the 300 hole. And it should be 476 in front of the wedge. And that looks good to me. I would call that good. Alright, so let's go ahead and prepare to save this cal. This is a done deal. So I'm at the 300 hole, and I'm going to bring that to 50% screen height and whole numbers of gain. Alright, 45 dB, freeze that. And I'm going to create a cal called 70JE. And let's see, where do I do this? File menu. File, create. I want a cal file, not an incremental cal file. And I'm going to call it 70JE. Insert 70 insert. I've been putting a little dash in there. Dash J E for Jimmy Ellis. That's my cal for my stuff. And I'm going to use the create and save function. Save the current settings. Yes. And we're done. We're good. I think I prefer to see this with my gate going all the way out past the 9th major division. So let me make an adjustment to this cal. Gates, that's the start. If I press gates again, I think it goes to width. There we go. And that's good. Freeze, save, overwrite, yes. All right, and that's the 70. All right, thanks a lot.